Hello everyone, welcome to this morning's CPD webinar on the Society of Light and Lighting Handbook. My name's Rebecca Kemp, I am the editor of FCNA magazine. Today I'll be joined by Tamlite Lighting's Darren Taylor, who is also a member of the Society of Light and Lighting. So let's begin with an introduction to Tamlite. With over 50 years experience, the award-winning lighting specialist boasts 9 UK factories, 400 stockists and holds 17,000 products in its extensive catalogue. This range of goods includes products that cover services within all sectors of the lighting and fire alarm markets. As for its project portfolio, this comprises names such as Cancer Research, Flymo, Pirelli and JD Sports. Darren is Tamlite's National Specification and Projects Manager. He's been working with the company for 4 years, bringing with him a wealth of knowledge and experience from the world of light. Being a member of the Society of Light and Lighting, Darren carries all the education, training and relevant expertise necessary to help deliver stunning projects across the country, working alongside a knowledgeable team of specification engineers. In this presentation, Darren will introduce you to the SLL Lighting Handbook, which is rewritten in 2018 and has undergone some significant changes. He'll be going through the basic structure of the handbook, highlighting a handful of key topics in its 3 main sections, and looking at some applications and key lighting points for each. The session will conclude with a look at 2 of the appendices and the information within. There's also an opportunity at the end of the presentation to address any questions that are asked throughout the webinar. So to ask a question, use the sidebar at the right of desktops. You can type in any queries you may have. For mobile users, it's slightly different. Swipe left to ask any questions, and then swipe back right to return to the presentation. All messages are private, so please feel free to ask any questions that you like. That's enough for me now, so I'm going to hand you over to Darren. So Darren, you're in full control now. I'm going to switch off.
Very much for that kind introduction. As you've said, my name's Darren Taylor. I'm the National Specification and Projects Manager for Tamlite Lighting. As you've also alluded to, today's presentation is about a book. Always a difficult presentation to get over, but essentially this is the Society of Light and Lighting Handbook. For any lighting engineers out there, this pretty much becomes our Bible for lighting, essentially. As well as myself, you'll hear a voice of a gentleman called Iain Macrae throughout the presentation. Now, for those of you who already know Iain, he was, or for those of you who don't know Iain, I should say, he was previously the president of the Society of Light and Lighting and one of the co-contributors of the presentation. So without further ado, let's start with the actual presentation itself.
Hello, I'm Iain Macrae, one of 24 volunteer authors, along with 39 other contributors who helped write the latest edition of the Lighting Handbook for the Society of Light and Lighting. This is really a major source of lighting knowledge, packed into about 500 pages of printed text. Of course, you can get a copy in PDF if you want. This time, the handbook has been completely rewritten and expanded, giving you even more information on lighting design, technology, and the application of light in a wide variety of situations through both interior and exterior. There are 34 chapters, that's 13 brand new chapters. There are some new appendices too, and it's about 50% bigger than the old version. We've taken out some of the fundamentals, put those back in the code for lighting where we think they belong, and that's left us more room for information we think will lead you through your day-to-day design and application needs. The handbook should in fact guide you through initial design decisions, through the selection of appropriate technical solutions, and then give you information around application, installation, commissioning, testing, verification, and indeed maintenance. I particularly like the handbook because it starts with people and their activities. It takes that experience and it adds things like well-being on top. You'll find some stuff on circadian lighting in there. You'll find some design issues, functionality, ambience, identity, accessibility, safety, security, all the stuff you'd expect. It also allows you to look at design constraints around professional conduct and the design process, and indeed how you would work with other people in that design process. There's plenty of guidance, plenty of legislation, links out to standards, design approaches. You'll find practically everything in here, and a lot of stuff about LED, power over Ethernet, lighting controls. In terms of the applications, There is now more chapters on communal building areas, places of worship, communal residential, places of entertainment, courts and custodial, transportation, extreme. This list goes on, doesn't it? But there's so much information in there, you can find practically everything you need. Where do you get hold of it? Well, if you're a CPD or SLL member, head across to the CPD Knowledge Portal and download your copy in digital format free of charge right now. If you're not a member or you prefer the printed document, again, head across to CPD. It's by far the best place to get it. Order online and you can have that book arriving through your front door or to your office a few days later. This really is a great handbook. It's the sort of thing you can access when you need it. It's got short, sharp paragraphs guiding you on information, perhaps taking you out to some of the lighting guides, which would have more detailed application information about anything you need. Great in PDF format because you can carry it around on a tablet and access it when you need, where you need, getting the advice you need. Highly recommended. Really, get yourself a copy.
Thank you, Iain, for that overview on the handbook itself. Like all handbooks, it's done voluntarily and it couldn't be done without the persons who are listed here today on this screen. These are all volunteers that make up the authorship. And again, I think we all owe them a debt of gratitude and thank you very much for what you've all done. So getting into the actual book itself, what's different, what's changed within the book? So there's 13 brand new chapters, so it's had a fundamental overhaul. It hasn't just had a little skim here. There's 3 new subject groups. We'll start looking at these in more detail, but the subject groups will be based on fundamentals, technology and application of lighting as well. The book itself is now 50% larger than it once was, so it makes up 500 pages. It's obviously difficult to know where we should focus our attention, but we'll do that throughout the presentation. There's 3 new appendices as well, dealing with reflectance and colour, also touching very briefly on circadian lighting. For any of you that are interested in circadian, there's a little bit more information towards the back of this presentation, but the book itself only touches upon circadian as a lighting source as well. There's also new appendices on building regulations, and then we also start looking at the design process, how we start a design and how we finish a design. So there's an awful lot more information in this book on the design process itself as well. So if we start to look at the lighting and vision, this is where we're going to start. You can start seeing where some of the sections have moved and some of the sections have stayed within. So effectively, what we're starting to look at now is things like lighting and vision. They've been removed from the handbook itself. They've been placed in the code for lighting. So this means the code for lighting now, if you're into the physics of lighting, i.e. the maths and the biology, if that's your thing really, then that's where you're going to start seeing some of that information now in the code for lighting. That's not what we're looking at here. Today we're looking at leaving the handbook to look at the practicalities, to concentrate on the day-to-day design, how we set out a design, and importantly, what processes we need to follow to incorporate a good design effectively. So part 1 now, we start looking at the fundamentals. So this is broken down into subsections. So things like the lighting design process. We start looking at this, day lighting as well, emergency lighting, design ethos and coordination of lighting. So these are the next few slides that you're going to start to see. But if we start off then with lighting design process. So if you're looking at a lighting design process, indeed, if you're serious about lighting design in particular, then this is the process you should follow. So you start by observing the definition. What is it you're actually looking to try and create? How are you trying to create it? And what is the client looking for? And we start that process with a process called, so we start with ideate, i.e. what's the idea? What is it we're trying to create? Then we go to creation. This is basically looking at how we create the design, what methods we need to use to put the design together. So things like making sure that we've got a defined light levels, making sure we've got defined areas of illumination, if things like vertical illumination are really important. So we start with the ideate, we go to create, and then critically we go to test. And if any part of this process, if along this journey we decide we need to start again, then again, we should be brave enough to go back to the start of a task and start that design theory again. And critically, I guess the most important part here is feedback. You should never be afraid to ask for feedback on your design, to ask for feedback either from the client or from colleagues, because look, more heads in a design process make better work, really. So in our opinion, this is really the way you should start out the design, and this is, you follow it through the process of ideate, create, test, and feedback. Really, really critical parts of understanding. And again, last thing, if at any point during that design strategy you need to go back to the beta to the beginning, then that's what we should do. We shouldn't be afraid of that. So then we start looking at things like daylighting. The daylighting chapter looks at 6 subjects effectively. So we start looking at things like the benefits of daylight. There's huge benefits from daylight. Let's be clear about that. As a lighting manufacturer, of course, we look at artificial lighting, but essentially the more that we can harvest and we can utilize daylight, the more we should in any of our designs. But we need to control that daylight. It's great having daylight, but how we utilize it is critical. So we start looking at things like the benefits of daylight, what benefits that has in terms of positivity on our health and well-being. And as I said, if we start looking at things like the control of daylight, so we do have things, problems with glare from daylight. We need to ensure we utilize control in that case, but also things like overheating. If the building is virtually glazed, then you may struggle with overheating from daylight. So things like this need to be taken into account as well. And clearly, privacy and security. We need shades not only to protect us from the glare from daylight coming in, but we also would look to use it, from a privacy point of view as well. So things like shading and different types of solar and anti-glare glazing-based technology, all of these are available to us. And all of these need to be taken into account. So if we start looking at things like predicting of daylight, where is daylight going to come and what angle is it going to come at, will help us to determine how we use shading and how we get the most out of daylight effectively. So it starts looking at anybody who's been doing their LIA or LIF or any other qualifications regarding lighting. You'll probably shudder now when you start seeing lighting, daylight harvesting and daylight controls in terms of calculations, because it is a busy calculation, but it's really, really important that we take that into account, because it is the natural source of light that we have available to us on Earth, as it were. So we need to utilize it. We need to harvest it. So we need to start looking at things like daylight solutions, windows, roof lights, etc. All of these things need to be taken into account when utilizing daylight effectively. And then it starts closing on maintenance considerations. So there are maintenance considerations, of course. You need to keep the windows clean, if indeed that is part of your design to begin with. The skylights, how many times have we gone back to buildings and they're not clean in any way and they're completely covered over, with outside degradation, etc. So if you're going to use daylight as part of your scheme, it needs to be maintainable as well. So then the guide starts looking at things like emergency lighting. Emergency lighting is obviously, it's very, very critical when you're looking at a lighting design from conceptual stage or refurb or anything like this. And the SLL guide teaches us the legislations and standards, the design approaches, what equipment we need, the planning, and indeed the installation, test, the maintenance. But I wouldn't be doing my job properly if I didn't say, before you look at any emergency lighting, any emergency design, anything on emergency lighting, you have to follow a full risk assessment. So the risk assessment will have been written up by somebody, a person of responsibility within the business, etc. And that risk assessment has to be adhered to whenever you're looking at design. But it's widely accepted that emergency lighting is there as a source when we have a power outage. It's not there for fires and things like this. So the SLL guide teaches us a little bit about that as well. There's CPDs specifically on emergency lighting as well. So please, feel free to ask on those later on as well, because there are specific CPDs just on emergency lighting. But the handbook reminds us there's a legal requirement to provide sufficient lighting to lead us to a place of safety. So essentially, within your building, if you're new to the building or if you've got a visitor within the building, then you must be able to guide that person out by means of secondary emergency light. And so the SLL guide teaches us what those light levels are and how much light we need in certain areas. Things like exit routes need to be illuminated to a higher level than, say, an open area, for example. And all of this refers, the SLL guide refers you back to BS 5266 as well. So anybody that's doing design, anybody that's doing light levels, light calculations, BS 5266 is where you'll get your actual numbers, be that 1 lux minimum, 0.5 minimum. It'll talk about things like escape routes and how we get people out the building to muster areas, etc. Lighting of staircases are all captured in 5266. The handbook just points you towards that. But the handbook goes on to describe emergency safety standby lighting in various design approaches. So again, things like high risk need to be taken into account when we're looking at emergency lighting. BS 5266 is the place to go for high risk task areas, but equally the SLL guide points you in the right direction. You'll also find things on BSEN 60598, i.e. the manufacturing of luminaires, and that is contained within the SLL guide as well. So then if we start looking at things like the design ethos, how we look to put a design together, what's the professional conduct for a designer effectively, and there's things called code of conduct. We look at simple things like professional standards on bribery, something perhaps we don't necessarily think impact our design choices, etc. But we need to consider these, and the SLL guide does point us in the right direction there as well. It also starts looking at professional standards and tendering, how we put a tendering document together, and it also starts looking at equal and approved status and sustainability. COP26 was just a couple of weeks ago. Sustainability is in all of our mind's eye, and indeed the SLL guide does point us in that direction. But within design ethos as well as some of these other areas, your life of a product, how long a product, the gestation of a product should last, and things like TM66 now start pointing us towards the longevity of a product, how long we can actually use the outer construct of the product and change the inner workings within the product as well. But it also teaches us, it gives us some inspiration on design, as well as looking at our safety of design as well. The Chartered Institute of Building Service Engineers was found in 2003, or found in 2013 when they did a survey. The 49% of the respondents believed corruption was common within the UK industry, construction industry. That's a really high number. So in 2013, they carried out this survey, and they realised that 49% of respondents believed there was corruption. That's something we can't have, and so professional standards and bribery are all covered within the handbook. So it sets out not only the professional standards in line with the CPD Code of Conduct, but it also starts looking at recommendations on how we should tender, how we should value engineer. Your value engineering is a terminology that we hear thrown around the industry day in, day out. But where is the value in the engineering? I.e., is it equal and approved, or is it just a cheaper alternative? And I think we need to start looking at these things in an awful lot more detail when we're putting design and tender process together. Also within the fundamentals of the guide, it starts looking at coordination with other services. There's a hierarchy of services, the coordinating of the ceiling void. I'm looking at this as a lighting designer, and things like ceiling voids and plenum spaces are absolutely critical because they determine what type of product I'm able to put into a project. And integration of air conditioning as well. It's a physically big unit, air conditioning, but from a lighting point of view, it can help me because LED lighting, LED as a light source, is temperature sensitive. So if I know that I've got good HVAC, heating, ventilation and cooling within the building, then I can look comfortably to use LED light sources in there without having to worry about temperatures. Just on temperatures, the colder, if we're using LED as a light source, then it likes colder temperatures. It's not best placed in areas over 25 degrees. And indeed, when you look at photometry on lighting manufacturers' luminaires, you'll see that it'll have an ambient temperature of 25 degrees built into the data. So heat does have a really significant effect, both positively in colder temperatures and negatively in warmer temperatures. So understanding coordination of services is a critical factor, really. So that's part one of the guide now sort of put in the can, so to speak. So we now start looking at part two, and here we start looking at things like light sources. We look at control gear, luminaires and luminaire types, power to lighting systems, and indeed controls. All of these are covered in part two. And critically, there's conventional light sources as well as new solid state lighting. So the SLL guide hasn't forgotten about the conventional light sources, and indeed identifying some conventional light sources. All of that is captured within part two. It also covers the control gear required to drive the light sources, and it discusses creation of things like scene setting. So if you're looking at, for example, illuminating a restaurant and you want 4 different scene sets, be that cozy light of sort of 5 or 10 lux during the meal, or if you're looking to bring patrons into the building, then you may have higher light levels. So we can start talking about scene setting. It also broadly discusses the luminaires that house the lighting sources. So it gives us a guide on where the light is required. So we start looking now at things like polar curves and photometry in the next few sections. And again, the power systems required for to energize the lighting in the first place. And then again, the controls. So the controls aspect now is becoming very, very key, whether that's just a simple presence control or whether it's a more technologically advanced wireless control with daylight dimming and daylight harvesting, etc. All of this is covered within part two of the guide. So if we start then, section 6 really is the next section of the extensive chapter, and this starts dealing with the characteristics, things like lumen maintenance. Any of you that do design lighting as designers, and you want to use things like calculations for maintenance calculations, all covered within these next coming sections. But it starts looking at color properties as well. Things like CCT, correlated color temperatures, or color rendering index as well. It starts looking at. It also starts looking at disposal of lighting, how we dispose of lighting as well. But it starts looking at things like light sources, and like I said, I think it's probably fair to say we would, as an industry now, but the story, I guess, the argument for LED is probably over in terms of life hours and burning hours, etc. So it starts looking at LED as a relevant light source, which it didn't do in the 2012 edition. But the chapter starts giving extensive information on light sources, starts talking about the positives and negatives of each as well. And as you read the chapter, it starts, as I said, to look at things like color, but it'll look at flux. It'll also look at restrike and run times. So particularly noticeable if you're using discharge as still your main source of lighting. Your run times and restrike times are fundamentally important to those. But it'll also start looking at things like luminous efficacy and indeed dimming. Importantly, it looks at the current market. It discusses light source, lifetime, and lumen maintenance, and all of those characteristics are what give us a maintenance factor, essentially. So any of you that are familiar with the old SLL guide, you'll see in the new SLL guide that it's been carried over. So we start looking at things like lamp characteristics. It gives you details on GLS lamps, general lighting service lamps. It'll give you details on that. It still gives you details on T8 and T5 as a light source as well as compact fluorescent, and indeed SONs and SOXs. We thought I guess they probably are a little bit of a thing of the past, but it's important to know, particularly when you're doing comparison designs, on LED, what were the actual source lumens of a SOX lamp or a SON lamp. Of course, you've got to take into things like light output ratios and losses, etc. But these are source lumens. But it gives you some details. It kind of nicely summarizes the key performance and criteria for each of the light sources. But critically, and I think this is the critical part, it backs it up with facts. These are the facts. These are, the source lumens. These are the dimming capacities, etc. That's available on these light sources. What is the control gear, etc. It also reminds us that solid state doesn't guarantee top performance. I think in some cases, again, we look at some of the numbers here, some of the life hours, and some of the outputs particularly, and you can see that the old lighting, the existing light sources can in some cases outperform solid state. Again, that argument is becoming looser and looser, i.e. it's becoming the LED light sources, solid state light sources are increasing in both performance and lifetime expectancy, etc. But it just gives you some comparison as well. And if we look at some of the output range, the efficacy column here. So if you look at sort of column 4 there, it starts showing, we can clearly see that some LEDs are poor performers. And this should be a reminder for us to look at and specify the light source, the right light source, not just automatically go to a particular light source. If you're only interested in LED, and as I said, as an industry, I guess around about 98% of what we produce is LED now. LED, incidentally, is a light emitting diode, and as you can see here on the left hand side, this is the cross section of an LED. So first of all, you'll see things like lenses. So LEDs already have their own lenses, their own optics built into them, but they'll have things like heat slugs built in as well, heat sinks, etc., solder connections, and all of the light produced from that LED, as you can see it by the distinct arrow there, is forward producing. So the actual light goes in the direction of which it's situated. So it does produce. So the SLL guide is not anti-LED by any means, and it does give you significant information on the format, the construction of LED as well. But again, I mentioned a little bit earlier when I talked about things like temperature sensitivity. LEDs are sensitive to temperature. We can't lose sight of that. It also starts talking to us now in these next couple of screens, or the next couple of graphs, I should say. The lifetime and what temperature has, what effect it has on things like lifetime of a product as well. So we can see in the center graph that the LED, the doubling of the temperature at the junction point can reduce the output by as much as 10%. Your 10% of a luminaire is quite significant. And equally, if we run that in the opposite direction, if you reduce the temperature, then you can increase the performance, increase the performance at the junction point of the LED light source. And then the right hand side, the very right hand side, the final graph is in relation to lumen maintenance and operating. So this shows you the difference between LEDs that are measured to a point of 10% when they're failed. So B10 is a number that we use, or compared to 50% of when they're failed. So these numbers get thrown around again by the industry. We talk about B numbers, B10, B50, etc. And this graph clearly shows you what the difference is between the life expectancy on a B10 product and a B50 product. So be careful of the scale. Although the curve does look steep, we're seeing a 10% drop from initially at 50,000 hours. And the difference between B10 and B50 is less than 0.5%. So although that graph looks steep, and although the number between B10 and B50 as a number is steep, we could be only talking about 0.5% difference between them both. But again, we also say, of course, other light sources are available within the guide, and so it's a good place to actually physically, look at a lamp and start identifying what it is. So, for example, if you're in the maintenance area of our industry and you look at a 2D lamp and perhaps don't know what that is, then it'll actually show you by physical appearance what a 2D lamp is. And things like MR16 lamps and things like this start becoming critical when you need to identify what they are. So the next section starts talking about terminology. And I think as an industry, I guess most industries have their own terminology of lighting, within the industry. But I think in lighting particularly, we have a great deal of terminology, a great deal of black art. So perhaps we quite like the acronyms, etc., of LED and MF, etc. But this starts to give us some insight into what the terminology is and what it stands for, what it actually means, etc. So particular interest here, you might want to look at sections on things like flicker. Excuse me, flicker. There's some really interesting detail now within the guide to flicker rate. Particularly important when you start to use things like video technology. So previously, I've been working on a project where the England Cricket Board used things like Hawkeye as part of their arrangement on video feedback and video playback on an internal design. And flicker has a real significant effect. On that particular specification, we had to achieve under 1% flicker rate. And you'll see a little bit later on in when Iain takes over a little bit, then flicker is starting to become a real problem, or not necessarily a problem, but it's something you have to focus on when using LED particularly. But the section also starts talking about things like dimming. It also talks about amplitude, pulse width modulation, all of these sexy terminologies that you may have been afraid to ask. Well, it actually explains what they are within the guide. There's also a short section in there on DALI versus DALI 2. The DALI technology has been around now a number of years, and more recently, DALI 2 has started to gain some traction. What is DALI 2? What does it do, and how should it work? Well, essentially, what the SLL guide tells us is that products that are identified and certified DALI 2, this is the critical part, they need to be certified as DALI 2. They're certified to work together. So effectively, out of the box, a DALI 2 driver will work with a DALI 2 sensor, irrespective of which manufacturers made that product. Now, that was the original concept, the original format with DALI, effectively. But as new people came to the industry and we started shifting some of the dictation, if you like, on DALI, then it started becoming a bit of a problem where out of the box DALI driver and DALI sensor might not talk to each other, they might not be compatible. Well, DALI 2 takes away that headache, and now we're saying as an industry that they do talk to each other straight out of the box. We touched upon it a little bit earlier. We're touching on it again here, Circadian, but again, like I said, Iain later on will talk to you a little bit more in more detail about Circadian in terms of the SLL guide. There's very little in the guide, it's fair to say. There's a section, a small section in there, and again, we'll give you some more details on that bit later on. So still within technology, but this time looking at luminaires now. Chapter 8 starts looking at distribution of light. So the images you see on the left-hand side of your screen here, these are what we as an industry would know as a polar curve. It's a distribution curve. It shows you where the light is going to go. So if I look at the first image, top left-hand corner, that is a very tight distribution of lighting, and it's all downward, as you can see. Whereas the image number 2 there will show me that I can get up and down light, so direct, indirect, etc. So it's a quick view on how we start realizing and defining the terminology of lighting, be that direct, indirect, etc. Then we start looking at the classifications then. So i.e. we look at the things like CE markings, CE markings or BSEN 60598, they both mean the same thing really. So BSEN 60598 are part of the requirements for CE marking anyway. And then we start looking at things like ENC, ENEC, so the European norms, electrical certification are all classified. So any certification that you're looking for when you're specifying products, etc., the SLL guide will give you an insight as to what they all mean. And they also talk about things like F marks as well. So this is flammable surfaces, products that are suitable for flammable surfaces, etc., will get an F mark. And then the center of the slide there just gives you a general feel of gives you images, some of the pros and cons on some of the products in the situ that you're going to put them in. Closing out part 2 of the book, this section starts looking at lighting controls. So it starts by looking at the terminology. So the terminology being manual, i.e. just a standard light switch, on-off light switch would be defined as manual. Presence is effectively the light fittings will be off, and when you enter into a room, the light fittings will automatically come on. It'll sense your presence, it'll bring the light fittings on, and then as you leave the room after a given period of time, the light fittings will switch themselves off. Well, absence, conversely, fundamentally used in things like classrooms in particular, but can be used in an awful lot more scenarios and will help us to save energy effectively. What absence does is when you walk into a room, the lights won't automatically come on. You need to actually physically switch a switch in order for the absence controls to come on. Now, the beauty of that is if you walk into a room and you're already getting, say, 500 lux through the window, you might not need the fittings to come on, and therefore absence is a way of not bringing the lights on automatically. But once you've switched the switch, as it were, if there's not enough light, then the lights will come on in the same sense a presence would. And then as you leave the room, again, in the same way a presence will, the actual light fitting will switch itself off. Next time you go in, you have to go through the same cycle again. The other switching mechanism is photocell. So again, things like bright out. This takes a little bit of education with clients as well, because sometimes you'll get a phone call to say the light fittings aren't working. Well, actually, the light fittings are doing exactly what they're supposed to do. The fitting will hold itself off until such time as there's not enough daylight coming through, and then the light fitting will bring itself on. You can also use things like daylight control and daylight dimming, which will actually use some of the light coming in through the window and subsidize that with artificial light as well. But in this case, we're just talking about a standard photocell. Then we start looking at the application. So again, we start looking here at the available illuminance from daylight. So we talked about daylight a little bit earlier, and as you can see, the numbers are flicking through here now as well. So how much daylight am I getting will affect how much artificial light I need. And again, this can all be done via controls. So we have what's called a constant illuminance. So it may be that you're getting 50% in through the window, and then you need the horizontal desk to be illuminated to say 500 lux. So you're getting 250 through the window from 50%. You may need 250 then artificial illumination to get you up to your 100%. And this is basically what we know and what we refer to as daylight dimming and constant illuminance, etc. These are the terminologies that we start touching on here. And then we talk about dimming as well, whether that's a mains dimming, a standard mains tungsten type dimming, or whether that's a Wi-Fi dimming, a DALI dimming. These are all the terminologies that are built up, and Bluetooth as well. And you'll see in the SLL guide, there's what's called SLL guide 14 as well, which is the control of electric lighting. So there's actually a whole section of controls, etc., within LG 14. And again, I urge you to have a look at that. So again, we start looking at things like Circadian, again within section within the technology section, Appendix 2. And this is basically the introduction of increasing color temperature, increasing light output, etc., throughout the day. So we wake up, during our cycle as cavemen, effectively, we woke up to sunlight and we went to bed as the sun set. So the dawn and dusk, the mentality. Well, clearly, with artificial lighting, we can stay in the same building for 24 hours if we so wish. Well, this is starting to look at how we adopt outside light sources in an internal fashion, be that the ramping up, like I said, of correlated color temperatures, or sometimes the ramping up of light levels as well. Then there's a section in there about LENI, the LENI calc. This is the lighting energy number indicator. It touches on how we code our lighting, our energy sources, etc. on lighting. Starts talking about the building regulations, and energy reduction is basically what LENI is all about. That's the fundamentals of it. And then the section closes off then with automatic testing and monitoring for things like emergency lighting. How you're going to monitor that system, how you're going to commission it, is also crucial. Hence the last part being commissioning and handover. If you look at things like the REBA stages, etc., you'll see commissioning and handover are critical parts of any building, and lighting is no less important. Commissioning and handover is really where you start getting the best out of the design that you put forward in the first place. Now, time is critical here, so I'm obviously not going to go through all of these sections, but parts 1 and 2 account for about 150%, so about 30% of the book. The next 270 pages are purely based on applications. So this is looking at things like the brand new section on communal building areas, but it also touches on lighting in offices, education, industrial, etc. But there's some new sections here, as you can see, in things like communal residential, places of education, places of entertainment, courts and custodial. All of these are new sections to the book, but it doesn't stop there. There are more, hence the 270 pages. So we have things like exterior workplaces, and exterior architectural is new as well. You know, how we start lighting the exterior, in an architectural manner, etc. are all brand new sections. And again, I'm time sensitive, so I'm going to push on. So if we start to look at things like offices now, so the chapter immediately challenges us to stop thinking about a typical office and start thinking about some new fresh designs. So, this is the stereotypical office, i.e. you might have remembered with a categorized louver, a shiny parabolic reflector, etc. It starts telling us to stop looking at it in stereotypical fashion, stop looking at it necessarily on 2.4, 1.8 centers, and start looking at other ways of lighting offices, particularly now with the way we're going to engage with offices in the next 5 to 10 years. The working from home mentality, or the hybrid working fashion. Do we want bidirectional lights with the upper section illuminated when there's only, say, one person in an office, so that building is still illuminated and it still doesn't feel cavernous and it doesn't feel dark around that one person necessarily, but saves us the energy of the downward light, etc. So we're still looking to facilitate quick and accurate work. I think that's the critical part about any office. We need to look at things like health and safety. We also need to look at comfort. Things like glare now we're starting to take into account at this section. Start looking at the tasks. What's relevant in that task? Face-to-face communication, or is it electronic? Face-to-face, we might look at things like cylindrical lighting on the face, to actually illuminate how somebody best sees somebody else's face, etc. Is the task now paper versus screen? All of these things are relevant, of course. Screen types are less problematic than they perhaps once were. So if you had a negative DOS prompt type screen, those are now a thing of the past, and positive contrast screens are now here. So they're less problematic in terms of gloss, etc. But the daylight availability and the occupancy are far too often ignored. So again, what hours is the building going to be kept? Who's going to be in there? How are we going to harness the daylight that we so valuably want to harness, etc. It also starts approaching things like direct and indirect light sources as well. So again, as I said earlier, it may be that you just want to use upward illumination when the building's only half occupied, etc. So then we start looking at things like the light levels within an office, your recommendations for normal versus intense tasks. Is it 300 lux or is it 500 lux? You're talking a significant percentage of energy difference. So if 300 lux is all you require for the given task, then why light it to 500 lux in the first place? Uniformity of lighting, that's never changed. Uniformity of the task, how we utilize or how we light the surrounding areas, how we incorporate daylight, etc. These are all critical parts, but uniformity has never changed. It's always been a part of our design ethos, I guess. But it also, in the SLL guide, reminds us that we need to illuminate walls and ceilings to avoid the cave effect. So we need to start looking at, or continue to look at those. Just because we've got a new light source, i.e. LED, doesn't mean that we need to change our design methods. Screen technology, again, can now cope with things like 1,500 to 3,000 candelas per square meter. Compared to 20 years ago, it was 500 to 1,500 candelas. So there's a significant difference with how much illumination we can actually put onto a screen now. And then it finishes off by talking about things like glare, unified glare, and how we utilize that and how we use it correctly, and things like discomfort glare as well. What's the difference between discomfort glare and unified glare? And then it talks about correlated color temperature. Again, it's always got to be a conscious choice. What temperature are we looking to harness within that environment? If the activity, I would dare say in an office, probably 4,000 would be a go-to product, but that might not be the go-to product of the designer. And wellness is covered in Appendix 2 as well. It hints with copying daylight as closely as possible. So again, correlated color temperature may be increased then. Anyway, I'm going to shut up a little bit now and I'm going to hear from Iain.
So UGR, it's a bit of a tough one. I mean, we've been dealing with glare in lighting and it's never been easy for many decades. We all understand the concept, a bright light source against a dark background that creates discomfort. It's just too intense for our eye. And if you put that at the extreme, then you get tiredness in the eyes and you get neck ache and you get headaches and so on. So it's something we've got to deal with for a well-being perspective. LED kind of changed that. Well, we went through a phase in the 1990s where fluorescent category 2 luminaires never had a glare problem. In fact, they almost seemed to suck up light. So the industry forgot about UGR. It went behind the boards and we didn't talk about it. Along comes LED, and the sheer intensity of that point of light, that 1 millimeter square point source, immediately recreates problems we knew about but hadn't had to deal with for over a decade. Along with that, we get new entrants to the market who know about electronics and create perfect luminaires, except not necessarily great optics, or know about how to apply the luminaires in a space. Suddenly we find yourself with a luminaire being offered on the market as UGR 19 compliant. Most of the market, of course, has forgotten that UGR is a glare metric applied to regular arrays of uniformly lit luminaires and light sources in perfectly rectangular rooms. And not only that, the observer sits 1.2 meters up from the floor in the center of each wall and looks across the space. So now with poor optics, you can have a problem of non-uniform luminaires, those individual points of light amongst a big diffuser or inside individual louvers. You can have modern office design where our rooms are not always rectangular, and you can have lighting designs where we don't often have, or perhaps we don't always have, regular arrays of luminaires. We might have wall washing and spotlights and downlights and so on. On top of that, UGR doesn't account for the dynamism of the eye or the worker in the workplace. We move around, we look all over the place, and UGR was really designed for a fixed task in a fixed location. So our modern working environment doesn't really fit with UGR either. Plus, add on top of that, we've got to move towards direct, indirect luminaires, and UGR really doesn't comply as a measure with luminaires that have more than 15% upward light. So you have to think about how you deal with that, and indeed how you deal with daylight and large amounts of glazing and reflection in screens and so on. There isn't yet a better measure. I mean, you can consider absolute intensity of the light source compared to its background, but you'd have to do that on an individual basis, and that doesn't give us an idea of the added glare and discomfort we experience in large spaces. So UGR is the agreed measure, and we have to apply it in a sensible way. But next time you're offered a UGR 19 compliant luminaire, don't just accept it. Take a careful look at the luminaire, take a careful look at its application, decide even whether UGR 19 is what you want as a designer, and take a step forward in detailed design and understanding what glare really is rather than just ticking the box.
So now we start looking at education. So thank you to Iain for looking at the office lighting there. We'll now start looking at lighting for education. And learning, you know, is as much about interaction and practice as it is about desk-based tasks. So how well you can see the teacher, you know, lighting the face of the teacher, lighting the as well as lighting the boards, etc. All crucial things. And again, we have to remember daylight first. Usable daylight index is covered within here as well. And Ian's going to take us through this.
Daylighting a learning space is really key to maintaining levels of alertness. And there's some good research out in the States that suggests daylight can actually increase learning rates in maths and other subjects too. So we really need to focus on daylight first, and that can be by usable daylight index, which is about a measure of the direct sunlight and daylight that enters a space, and we're looking for 100 to 3000 lux roughly for 80% of the core hours. That was developed by John Modelovich up at Loughborough University, so go and have a chat to him on that one. You can also have daylight autonomy, which is more an American-based but still a very valid measure, and that's 50% of the working plane to receive about 300 lux for 50% of the core hours. The key thing to remember is it's not about excluding daylight. Daylight is our primary source, and then for the evenings, for the dark times, then we add in artificial lighting on top of that. So we need really great controls to inhibit that lighting when it's not required.
Continuing with education, and again here Iain Macrae will talk to us a bit more about that.
So I always get a couple of questions about why lighting levels vary in classrooms for children versus adults. And it basically comes down to the quality of your eyesight. The older you get, the more light you need. So generally for students of a younger age, 300 lux on the horizontal task is enough. We still need to light the face, so we measure 150 lux cylindrical. That's around the face of the teacher standing up, so about 1.6 to 1.8 meters up in the air. And that naturally gives a modeling index of about 0.5, which is fairly soft. For adults, we go for about 500 lux on the horizontal. They're going to need to have more light in order to read the same level of text. We keep the same light on the face of the teacher because generally we can recognize facial features more easily. The brain is really programmed to recognize faces and to read body language. And that gives a slightly harsher modeling index of about 0.3, but adults won't have any problem with that. UGR in classrooms, generally not a problem. Actually, it's normally daylight that's a problem. We have to control the sunlight ingress into the space, and we need to make sure that the whiteboard doesn't have glare on it, because that can literally stop students reading the text that, or the diagrams the teacher's putting up there. And then the final one, which is growing in importance right now, is flicker. We talked about flicker a little bit earlier in the seminar, but in this case we've put a standard on it. We talk about the IEE 1789 standard. That gives a minimum flicker frequency of 162 Hertz and less than 3% flicker factor. And that's pretty important for young eyes, and also to control the quality of the light and indeed the quality of the luminaires we're putting into our teaching spaces. Final point, of course, is emergency risk assessment. Do a risk assessment, analyse the space, analyse its use. Never, never, never just put one luminaire above the door just because it feels right, because that really doesn't satisfy anything at all.
So those two areas now covered. Now let's start looking at things like maintenance now. The requirements for maintenance and a maintenance factor effectively. And again, I mentioned it earlier, anybody who's been fortunate enough to do lighting as part of the LIA or LIF or anything else, then you'll have done some of the calculations you're about to see now. But this is the guide, the BSEN 12464 guide on how to create a maintenance factor. And it's crucial that you understand the maintenance factor, because if you're just using software programs, it'll automatically default to a position, whether that's 0.8 or 0.6 or whatever. It'll automatically default to a position. So it's crucial you know how to build your own maintenance factor, just to double check. And the next few slides is how we do that. So we start then, maintenance factors, the needs and requirements. So again, what's the impact on the scheme from things like depreciation? What's the impact from things like dirt and degradation, etc.? Not guessing, not simply saying 0.8 is again crucial, because it'll impact the longevity of your scheme effectively. Low maintenance factors do have an impact. It's very important that we say that. So the lower the maintenance factor, of course, the increased quantity at the start of the project you're going to need. But equally, if you see a scheme where it says 1 as a maintenance factor, and sadly you do see them from time to time in the industry, I question your designer or I question your manufacturer to make sure they've taken the appropriate steps, because all luminaires and will have outside degradation, be that dirt or dust, etc., as well as the lifetime expectancy of the product. So seeing 1 as a maintenance factor may be a red flag to you. You might want to start looking at that design in a little bit more detail. So plan for a maintenance point rather than just using an LED lifetime is another crucial factor. When do I want the life of this product to end? Start looking at things like that. But the handbook deals with things like lamp lumen maintenance factor. It starts looking at luminaire maintenance factor, as well as things like room surface maintenance factor. Again, things like luminaire and room surface maintenance factors haven't changed, so they need to be calculated. They need to be installed within the calculation. So again, you can see some of the graphs now on the right hand side. These are talking about cleaning surfaces. Is a building clean? Is it normal? Is it dirty, etc.? How often is it going to be cleaned? All of these things will have a major impact on the maintenance factor to begin with. So the final thing then is lamp survival factor. Depends on spot or group replacement. So are you going to change every time a lamp? If we talk about it is an old light source, every time a lamp goes out, you can immediately change that lamp, or are you going to wait for 10 of them to go before you change the lamps? All of these things have an impact on the maintenance factor. And lastly, you'll see the maintenance factor is built up of all of those 4 criteria, the aforementioned 4 criteria. So all of those 4 numbers will give you a maintenance factor at the end. And I'm conscious of time, but I urge you to do that calculation. I'm pretty sure it won't come out at 1 anyway. So again, starting to finish off the presentation now, we start looking at things like the fundamentals and applications are now over, but we start looking at things like appendices. So reflectance and colour, circadian, there's that word again, circadian lighting, and indeed building regulations, environmental labelling of schemes. And your host again, Mr. Macrae, will take over in a short while and start talking to you a little bit more depth about colour. So if we start looking at the first appendix, which is colour and reflectance, and again, here is where I hand over to Iain, because he says it a lot better than I do.
So the chapter on reflectance and colour really deals with the quality of light you're putting onto a surface and that surface's reflectance properties. So you put great quality light on, the colour will be brought out truly. If you miss out some colour spectrum, then of course the surface can't reflect that light and you can't see that colour. Now, it should pique your interest around LED, because in the marketplace there's this theory that all LED really struggle to bring out the reds, and that's not really true. So if you look at figure A1.8 in the handbook, what you find is this wonderful table by Gerard Harbers, and this shows a good quality RA80 good colour rendering LED versus an excellent colour rendering LED, and indeed some other light sources too. And look at that top line. What really matters is the R9 value. R9 is missed by the general colour rendering index. It's only picked up by the extended index, and that's not the index that most manufacturers publish. So as a designer, go out and ask for the R9 values. Actually ask for the R12 value too. That's really interesting. So we can see on this LED RA80, the first 8 scores are pretty good. Their average, they give us a rendering of over 80. but the R9 value is down at 16. That's pretty poor. That means the reds are not going to pop. They're not going to be brought out truly. If you use this LED to light red material, steak in a supermarket, for instance, it's just going to die. So look at the excellent LED rendering below that. We've got a score of 98, go all the way across the board into the extended values, and we see an R9 of 96. In fact, the poorest value is the R12, and that's because the blue produced by an LED generally is not the right blue to be reflected by the color sample, but it's still pretty good at 88%. I wouldn't worry about that one. The only difference, the quality of the phosphor. The phosphor changes the blue light energy generated by an LED into the white light we see. The R9, 10, 11, 12 values all depend on the quality of that phosphor, and so you need to buy a slightly more expensive LED. All it is about technology choice. Sacrifice a little bit of energy for some great color, and there's really not a problem. The handbook also goes on to talk about CIE 224. We used to know that as TM-30-15. That's the extended color rendering index based on RF fidelity values and RG gamut values. Worth a look. What you'll find is the color rendering in RA8 versus color fidelity RF will be about the same. They'll probably be in 1 or 2 points of each other, but the color gamut allows you to look at those other values comparing to a reference light source and see whether you're going to enhance or diminish the color. So if I have a high R9 value, I'm going to make reds look artificially enhanced, or I'm going to make them look just fantastic. Or indeed, low R9, am I going to diminish the red so it doesn't pop at all?
So then we move on to circadian lighting, and again, who better than Mr. Macrae to go through the ganglion cells, etc. And I hand over now to Iain.
So finally you make it to Appendix 2, and it talks about circadian lighting. And it gives us the background. So we've known for a long time that there are ganglion cells just below the surface of the retina. The rods and cones are actually a little bit deeper in the retina. And we found that some of these respond to light. In fact, over a period of time, a short period of time, probably about 2 hours, if these IPRGCs fail to receive light, then they trigger the secretion of melatonin, and that triggers our sleep or our need to sleep. Now, recent research suggested a peak sensitivity about 480 nanometers. That's deep in the blue. And of course, everyone comes along and says, whoa, if I introduce a blue pulse of light for a significant amount of time, then I can wake people up. And indeed, at about 480 nanometers, you can inhibit melatonin production, and therefore you keep people awake. Whether that's a good or a bad thing is another matter. Recently, we've found that actually the IPRGCs respond to different wavelengths of light, not necessarily to the same intensity as blue light, but there is a lesser effect, but it's still an effect. And time and exposure are key. So the handbook goes on to explain how research developed a little bit, ending with some research by Lucas et al. In 2013, which developed this alpha-opic illuminant sensitivity curve. And this is the idea that actually you look at all the secretions done in the brain in response to light, and you see that the response curve varies right from 380 nanometers right up to nearly 700 nanometers. So there is a response to all colors of spectrum. And that leads us to the conclusion that simply changing the color temperature isn't a good indicator of what the spectrum is, and that isn't a good indicator of what the circadian effect is. But this research was used to develop some insights into, if you know the spectrum of a light source, you can work out what its circadian impact will be, what its melanopic impact will be, and indeed you can extrapolate that out to melanopic illuminance if you want, the equivalent effect of daylight. What it doesn't really tell you is about the intensity, and we still have to look at how we use spaces with the right amount of light for the right amount of time and the right spectrum of light to see what its circadian impact really is. The problem we've got at the moment is most of the case studies lack comparative data. They're not double-blind tests or regimes. They use subjective questionnaires, and they don't really go back at a later date and monitor the impact on secretion levels and so on. So it can be used. It's a really interesting bit of research, but we've got a little bit of a way to go yet. So I said that researchers don't agree, and indeed the handbook pulls this up. Lucas and the CIE urge some caution. In fact, if you look at Lucas's report, he comes back and says it's not always clear whether lighting design should aim to maximize or minimize the non-visual responses. So light is considered a drug, and we have the potential for both benefit and deleterious effects. So there's some conflict here about whether we should put circadian lighting to the space, given that we don't know what the long-term effect would be. The CIE essentially says the same thing. You know, it's important to have a tailored lighting application for people, but you need to understand the concept and the long-term effects. If you look at Macrae, the well-being standard, even some German standards, DIN standards, they all suggest we forge ahead. So it's quite understandable in the marketplace. You have one group of people saying, yes, circadian lighting, we should definitely put it in, we should use it, and others urging caution. And I think as a designer, that's what you should do. You should look at the latest research and decide whether you're open to affecting people long-term and whether you really know what the effects are. When those become clear, then perhaps circadian lighting will be a thing of the future. So circadian lighting demands balance. In fact, all lighting design really demands balance. It's not just about reading numbers out of a book. And the handbook ends on a nice note, I think, with circadian lighting, because what it says is, okay, go and look at age. You might be old, you might be young. The amount of light, and indeed therefore the amount of circadian light you need, will be based on your age and your eye's ability to pass that light back to the retina. There'll be some impact on personal preference. You know, do I want to choose a space which has warm color temperature lighting, therefore more red content, or cold color temperature lighting, therefore perhaps less blue content? Or should I actually put a spectrum of light into a space that is there deliberately to impact my circadian rhythm? And that's a difficult one to balance. Thirdly, there's illuminance. There's demands to reduce the amount of energy used in interior lighting schemes. That means we're driving the illuminance levels down, or we're driving the efficiency of lighting products up. But actually, circadian lighting might demand more light towards the middle of the day, and that will increase the illuminance level. So we have to balance this energy versus health requirement. Then there's blue light. Currently, most luminaires sit in a low risk group for blue light. We've controlled them really well. We put them out of locations that cause damage to the retina and to the lens. But if we start increasing the amount of blue light and the illuminance, then we could run into problems with damage to the eye, and we need to be careful with that, especially with the young. And then finally, of course, there's flicker. We need to balance changes in light over time, and indeed using new LED technology shouldn't be a problem, but you can get LEDs that flicker on and off visibly versus those that are static. And we need to make sure that when we're putting dimming systems into spaces that we're not introducing other problems that impact our health and well-being too. So circadian is a really exciting lighting discussion for the future. It's something we should really be keeping our eye on, but there's no concrete way forward just yet. Take a little bit of care is what the handbook suggests.
So that's the end of today's presentation. Thank you ever so much for giving us your time today. Again, I hope you got something from it. Again, it was a presentation on a handbook, but hopefully it gave you some knowledge as well about lighting in general. Now going to hand over to Rebecca if there's any questions you may have. Thank you ever so much for your time.
Thank you, Darren. We've had a few questions come through. So the first one is, in your opinion, what would you say is the most important change that's been made to the handbook?
Thank you, Rebecca. I think, again, it's all about opinion. In my personal opinion, I think how the design ethos of the book has been well put together here. I think it gives us a flavour on how we should design, how we should start a design, with the notion of ideate, but also not be afraid to go back and challenge some of those designs. And I think that's been a fundamental aspect to the book.
Excellent. Do you think there are any elements of the handbook that fall short on today's requirements? Sorry.
That's okay, thank you. I guess, look, the handbook was written 3 years ago in 2018. In 3 years, I guess an awful lot has changed, and I think things like the introduction now of TM66, which is the technical memorandum that's been written by the Society of Light and Lighting, been very well put together. Perhaps if that was around in 2018, that perhaps would have been formed a part of this as well. But I urge you to look at things like TM66 in conjunction with the SLL handbook. Was there anything missed at the time? No, for sure. Has there been advancements in 3 years? Yes, there have. And so looking at external documents in association with the handbook, I think will serve us all well.
Excellent. Okay, obviously you touched on office design within the presentation. How do you think that office lighting design has changed in a post-pandemic workplace?
I think I tried to touch on that a little bit during the presentation, because it definitely has changed and will continue to change for the coming years. I actually put a presentation together a couple of months ago on office design in sort of 2021. It's a really hard concept to get your head around, really, because you never quite know whether or not you're going to be lighting an office for one person now, or whether you're going to be lighting it for 100 people. And I think that's a real critical part. And having control over your lighting, I think, is never been more fundamental than it is today. Because clearly, if you're lighting an office for one person, that one person still has to feel welcome within an office situation. That one person still needs to feel comfortable and safe within an office environment. But clearly, you don't want to light it as if there's 100 people there. So as I touched on earlier, things like bidirectional lighting, whereby you might only have the bidirectional aspect over a few of the desks, and then the indirect aspect over the remainder of the desks, might be a flavor and a way of doing that. But I think controls are our friend. Controls are here to stay, and we need to harness controls when we're looking at our modern offices, for sure.
Perfect, excellent. And what do you think is in store for the lighting industry across the next decade?
Wow, really tough question. I think, again, more of the same, really. I think, look, the lighting as a source is here to stay. Like LED lighting is a valuable light source in terms of energy efficiency, longevity of hours. That's here to stay. I think, again, bringing TM66 back into play here, the way that we're able to upgrade a light source will significantly change in the next 10 years. So a plug and play attitude, a Zaga type attitude, whereby you can take the light source away from the body of the fitting, so only things like the steel remain, I think will be in the next handbook for absolute sure, and will be with us for the next 10 years. How we recycle the products, how much recycled products, materials we put into the product to begin with, is becoming fundamental on specification now. And again, our old friend controls. I think controls have the answer to lots of our questions. Whether or not we book an office out, and therefore the lighting dictates whether or not the heating is on or the air conditioning is on, I think is here to stay. And how we address our emergency lighting as well, I think will be revolutionized in the next 10 years as well. So SLL Lighting Handbook for 2028 will look significantly different.
Excellent, perfect. I hope you found that very useful and informative. And if you do have any questions that you think of after the presentation, you can send them across to Darren. We're going to put his email address in the sidebar for you to copy and paste into your emails. Also, it's worth adding that this webinar will be available to refer to at a later date and will be hosted on the FCNA website and its sister title, Public Sector Build Journal's websites as well. I'd like to thank Darren, our speaker, for his time and imparting his knowledge. And I'd also like to thank you, our audience, for taking the time out and sending across all your questions. It's really made for an interesting discussion. So thank you, everyone, and goodbye. Thank you.